The basic question, elementary question which I was, or which I did ask you. The elementary question which I did ask you the other day was, why is that fission or fusion? So if I am to distinguish fission being the break and fusion being amalgamation, right? Yeah.
Yeah.
Breaking and fusion is amalgamation, right? Rishabh.
Yes.
So let me be and ask, as I did upload on the same, that why is that if I am breaking a heavy nucleus, any heavy nucleus you take, any single heavy nucleus you take, or is that take a set of nuclei, if you break heavy nuclei into lighter nuclei, if you're breaking a heavy nucleus, one heavy nucleus, into lighter nuclei, which we call lighter daughter nuclei, which is what is being termed as fission reaction, right? Yeah.
Yeah.
So my question was very simple, which being, why is that breaking off parent nucleus into daughter nuclei to get me energy, right? Yeah. Why
Yeah.
is that breaking off parent nucleus into daughter nuclei to get me energy? What is essentially there which is camouflage? What is essentially there which is yet to be surfaced? Which is responsible for energy? What is there yet to surface, yet to be surfaced by me, which is in which we can say is somewhere the repository of energy? What is that element? What is the crux? What is fulcrum of my argument? Yes, Risha. Which is what I did update you with. I have sent you notes, and from there, at least this could have been deciphered that what is the primary reason for energy being liberated when we are breaking a heavy nucleus into daughter nuclei, right? Yeah. Right? Yeah.
Sir, can you repeat? Actually, your voice
What
is
is,
breaking.
where lies the crux? Where lies the nub of the issue? Where lies answer to my question? And the question being fulcrumed on, there is a point on which it is linked. And it being, I get energy from nuclear reaction. So if my argument
Yeah.
being I am getting energy from nuclear reaction, then what it is pinned on? What is this energy to be attributed to? What I am to
Yeah.
ascribe this energy to? From where I am getting it? What is its source?
So,
I sent you
so when
pages
during
right
nuclear.
here. Can you get me those pages first? I have sent you a few pages. Can you get those pages in front of you?
Yeah, 1 second.
Get them. And please don't lose sight, Rishabh. Please show me yourself. Show me yourself.
Yeah, 1 second. Sir, it's reconnecting.
Okay. No, sure. Fine. Let me. Please don't lose sight, Rishabh, that you are over here for greater cause, right, dear?
Yeah.
Please understand that you are over here for greater cause. And the
Yeah.
association is going to be very long. You are over here for ITJ foundation course and it will see up to ITJ gates, right, dear?
Yes, sir.
You are here after of an examination, you are privy to students taking examination yet being not enrolled. You are known to it.
Yeah.
You are also known to that student taking examination being enrolled but not passing in the intermittent test being asked to withdraw. You are known to it. So much so that the student is there in SNN itself. And I'm talking of this year ITJ. Out of 7, only 1 was asked to withdraw, and all 6 did. All 6 did qualify except for that one guy.
Yes, sir.
Okay, so please try understand and don't lose sight ever of what is this association for. This association is for ITJ, and we are to toil hard and get whatever in our capacity for it. Whatever result is in the hand of Almighty, we can't say. We have to accept whatever is being bestowed by Him as blessings, and it is. But
Yeah.
we should not shy away from trying, from making efforts, right? Yeah.
Yes, sir.
Okay. So
Yeah.
please, whatever
So
being told to you, what have been asked of you, it is expected that you reciprocate in the manner what I do. At least, if I am
yeah.
doing, I can ask for that reciprocation. I do have right. Correct? Yeah.
Yeah.
Okay. So tell
So
me if there is a
during
heavy, yes, one heavy nucleus. Example you cite. I remember I have uploaded a question, correct me if I'm wrong, in which I have shown you that there are four. First, I have shown you that there are two protons and two neutrons.
yeah.
Okay, and then I told you that there are four protons, correct? Yeah.
Yes, sir.
So basically, what I'm talking of helium, correct? Yeah.
Yeah.
Nucleus of helium atom, correct?
Yeah.
And then I told you that let us break this nucleus of helium atom into constituent nucleons, right?
Yes, sir.
So if you break nucleus of helium atom into constituent nucleons, why I'm saying it is nucleus because we have denoted it of electrons, correct? Yeah.
Yeah.
Okay. So, and you know that proton can convert in, neutrons can convert into proton easily. That conversion we'll study about later. So, from two neutron and two proton, we are left with four protons, correct?
Yeah.
And four protons that we are talking of, they are then shown in a process where they are being shown undergoing a process where they are to break. That means the nucleus taken will break into constituent nucleons, right?
Yes, sir.
And then I told you, I have made you write something on their mass. Could you please read that out for me? Something on their mass. Look into the notes and tell me which is higher on mass, which is higher measurement on mass. Is the parent nucleus or the daughter nuclei?
The daughter nuclei.
The daughter nuclei, what are they?
Um, 1 second, sir.
Collectively, what are they? More on mass, less on mass.
More on mass.
So collectively, they are more on mass. Is it so?
Yeah.
So if I go reverse, Risha,
Yeah.
what did I say? If I go reverse, if
Yes,
I go
sir.
reverse means when the constituent nucleons, is it okay? When the
Yeah.
constituent nucleons, when four protons over here
Yeah.
are to amalgamate, are to merge, are to collate, are to coalesce. If they are to coalesce, then what will
Yeah.
I get? I'll get one nucleus, correct? Yeah.
Yes, sir.
But that nucleus will be less on mass in comparison to four nucleons, right?
Yes, sir.
So there is a reduction of mass, right? Yeah.
Yeah.
So if I go
And
for the process of fusion, what did I say? Process
fusion.
in which it has got fused. Yes, I'm talking of nucleons over here, no issue. Because I want to relate it with mass primarily. Got it?
Yeah.
So if there is decrement on mass ratio, then coming from the other day class, I told you, mass is nothing but condensed form of energy, correct?
Yeah. So this loss of
When
mass is
there is
converted into
reduction
energy.
of mass, yeah, Rishabh, you were asking something.
Sir?
You were asking something.
So, sir, this loss of mass is converted into energy, right?
Yes, this loss of mass is to appear in form of energy because mass itself is condensed form of energy. So in a
Yeah.
way, I'm losing energy. Yes,
Yeah.
what energy I'm losing, you'll get to know later. We get a formula which is delta mc square. Delta m is
Yeah.
the change on mass and c, as you know, is speed of light. So delta
Yeah.
mc square is the energy. And let me tell you, 1 AMU, nowadays we don't call AMU, we call universal mass, as you know. So 1 universal mass, so small mass, will get
Yeah.
you 931.5 million electron volt. 1 AMU gets you as much as 931.5 mega electron volts, you can say, or you can say MEV in short, million electron volt. Is it okay?
Yes, sir.
So this is the energy which 1 AMU can get me, 1 universal mass can get me. Think of
Yeah.
delta M. Delta M is pretty high, correct? Yeah.
Yeah.
If you talk of delta M being high, you can very well guesstimate what energy you can get of a process fusion. Correct? Yeah.
Yes, sir.
And this process is very much possible. There is possibility of heavy nucleus breaking into lighter nuclei and is in equal probability lighter nuclei getting fused so as to find virtue and get what there get their reaction which we name fusion. So both the processes are equally viable. Are you getting it?
Okay. Yeah.
Both the processes are equally viable and both the processes are to our good because both the processes are to get us beneficiary of an term which is essentially required for living and that being energy, right? Yeah.
Yes, sir.
Okay, so let me cite the example as I have taken the reverse logic. And on reverse logic, what we did cite that constituents of a nucleus, or as we call nucleons, they will
Yeah.
combine, they will merge and merge to get one nucleus to you and energy.
Yeah.
Now, if you want to break that nucleus, Rishabh, right?
Yeah.
If you want to break that nucleus and go back to the state that it was in constituent nucleons, will it be easy for you to break it? No, it will not be. Why? Because the energy which got in a way which I was beneficiary of or which got by the reaction liberated, that
Yeah.
energy is no more tapped by me. That is in ambience or I have made good of that energy. Now mass of nucleus is less than mass of constituent nucleons, correct? Yeah.
Yes, sir.
If I want to get back to the initial state, then I'll have to add mass, correct?
Yeah.
So I'll have to do work. I'll have to spend energy, right?
Yes, sir.
And the energy that I have to spend to break a nucleus into constituent nucleons is called binding energy of nucleus. Got it?
Yeah.
That is the energy by which nucleons in a nucleus are bound, right? Yeah.
Yes, sir.
Nucleons in a nucleus are bound by some energy. Otherwise, they will not remain in the form they do, right? Yeah.
Yes, sir.
And what energy they are bound by? Energy which got liberated. Why did the energy get liberated? Why did the energy get liberated? Energy got liberated because mass of constituent nucleons were to be seen, collective mass was to be seen more than that of the mass of nucleus, which
Constituent
I
nucleons.
got by amalgamating the nucleons, right? Yeah.
Yeah.
So you can
Yes, sir.
relate what is binding energy. You can relate why we will get energy when the process taken, undertaken is fusion, correct? Yeah.
Yeah.
And I also cited an example in which uranium was bombarded with neutron.
Yeah.
Uranium was bombarded with neutron to get you U-23692, which I
Yeah.
told you will break into krypton, barium, and 3 neutron. And the process you will get energy. This is fission.
Yeah.
Previous was fusion, correct? Yeah.
Yes, sir.
Previous was fusion, and this one is to us fission, correct?
Fission. Yeah.
So
Yes, sir.
uranium 23692 will break in barium and krypton and 3 neutrons. Now I'll
Yeah.
ask you to clip and go to page number 3 of the one that I have passed, shared with you, and tell me, what did I write about the mass? Left and right of indication. Left and right of the arrow indication. What did I write? Check what is there. Right top page.
Yeah.
What is there? Is there uranium shown to you, bombarded with neutron?
1 second, sir.
Uranium shown bombarded with neutron. Check once. Right top. How many pages did I pass? Check once. 6 or 4?
Only 3. 1,
3.
2.
So I think second it must be, right top. No, second or third? Not shared?
No, sir. 1 second.
Uranium. But I think I have. Just a minute. Hold on. Let me ask you, have I sent this to you or not? These are few that you won't be getting, and many other which I will make you write later. I didn't share this with you, didn't I?
Yes, sir, you have. Yeah.
Exactly. That's what I'm asking there. Okay, third or second page top?
Second.
You 236.92 you got, x plus y I have written, but
Yeah,
x is
yeah.
barium and y is krypton is what we
Krypton.
get in general, barium and krypton. And what is rest mass of product? What is rest mass of product? Rest mass of product is smaller than rest mass of uranium, correct? Yeah.
Yes, sir.
This is which reaction? Fission reaction. And here what
Yeah.
you get, rest mass of product that you are getting is lesser. Cumulative mass of product being lesser than that of the
Constituent
parent material, parent element. And parent element over here being uranium, right? Yeah.
uranium. Yeah.
So what will you say? What happens to mass? Got lost in thin air? Is the mass to get lost in thin air?
Yes, sir. No, no. It is converted to energy.
Mass getting lost in thin air means what to you? Mass will vanish?
No,
Vanish
sir,
like skin of your tooth? Will it vanish like skin of your tooth? No, of course not, right? Yeah. What will happen then?
It will convert to energy.
Good. Because mass is condensed form of energy. So this mass, the loss is getting converted into energy.
Yeah.
And that is the energy which is what we are to relate to fission reaction. Is it okay? Dear fission. Getting it?
Yeah. Yeah.
So be it fission or fusion. If it is controlled, then we can find virtue in these reactions because we get quantum of energy release. Correct, yeah? Yes, there is always a risk of leakage and it can contaminate environment, as you know. So those part we are to run a risk and very calculated we do. If we are alarmed, if we are cautious, we can make a rank good of this process, right? Yeah.
Yes, sir.
Okay. Anyway, this is the last segment, contemporary energy source, as you know. But let us go to the other ones. The other ones, by that what I mean, we are moving the chronology and we saw up to energy related to dam, right? Yeah.
Yeah.
Why do we build dam? What is hydroelectric plant based on? And where are they suitable to be constructed? Correct? Yeah.
Yeah. Yes, sir.
So elevation can be one of the boon in their construction. Hilly area, natural water flow or natural waterfalls can be a boom in their construction. If not natural, we make it so, human made. Correct, yeah?
Yes, sir.
Okay, but tell me what can be a drawback for the same. See, essentially, let me tell you, Rishabh. Essentially, this topic is theoretical, right? Yeah.
Yeah.
So it's not that there are formulae, you will solve questions based on formulae. That is not the case.
Yeah.
This is theory, pure theory to you. So please make it very clear that you go ample of time and be very selective on the uses of words. Is it okay? The
Yeah.
choice of words should be without of ambiguity. Clear, dear?
Yes,
Should
sir.
be crystal clear, not being ambiguous. Fine, dear?
Yeah.
So for that, you need to take multiple reads. Fine?
Yeah. Yeah.
Okay. Tell me then, Rishabh, what comes to you can be one major hurdle, major hiccup, major contention, actually is healed, let us say, in this
So,
construction. Because this construction doesn't require much of maintenance, you know that very well. Yeah,
yeah,
initial
but
construction cost may be very high, but
yeah.
once being done, it doesn't require much of maintenance. So what can be one, according to you, one drawback?
So not all the water sources are suitable for hydropower generation.
Okay, fine. Not all water. Could you please elaborate on it? What do you mean by water property?
No, I meant not all rivers or lakes can be suitable for hydropower generation.
Say it's about volume of water. So not
Yeah.
all may be perennially. Not
Yeah.
all may be perennially around the year, perennially with
Yeah.
that quantum of flow, right? Yeah. But
Yes.
that can be addressed by constructing dams,
Yeah.
isn't it? Dam can
Yeah.
even harvest rainwater, right? Yeah.
Yes, sir.
Okay. So major problem being the area, right? Yeah.
Yeah.
Huge area require volumes of water, right? Yeah.
Yes, sir.
Quantum humongous amount of water. So rehabilitation, as you know, there was a lot of buzz around. If you can recollect, there was a lot of buzz around Tehri Dam, Sardar Sarovar Dam. Tehri
Yeah.
was to be constructed on River Ganga and Sardar Sarovar on Narmada, right? Yeah.
Yes, sir.
So those activists, they have their motives, of course. It is not that they are holy cows. They have their own motives, own agenda. They don't want India to see progressing. So they make hue and cry. They shoot off the shoulder of people, right? Yeah. In the
Yes.
garb of people, human right, what they do, they have their own agenda. But they do generate buzz. And that being what was generated then, that how will you rehabilitate this number of people, right? Yeah.
Yeah.
So that is not the major contention. Yes, one can say that rehabilitation is required and government do provide. So that is one part. Then also vegetation and everything which is getting submerged will get rot as well.
Yeah.
And that rot will be anaerobic.
Yes,
Anaerobic,
sir.
aerobic, you know.
Yes, sir.
What is anaerobic exercise? What is aerobic exercise?
In which oxygen isn't utilized
So
to produce
anaerobic means
energy.
you cut the supply of oxygen, right?
Yeah.
Anaerobic. So you are in want of oxygen. You are in paucity of oxygen flow, right? Yeah.
Yes, sir.
So in that destitute, if something is to decompose, then it is called anaerobic decomposition. And anaerobic decomposition we can be beneficiary of as well if we are able to tap gas release. Generally, anaerobic decomposition of plants will get you abundance of methane released. Is it okay?
Okay.
Or I tell you what will be an abundance release? Methane.
Methane.
If you're able to trap, it is to your good. If you're not able to, and it'll be difficult for you to trap in a dam that energy. So we say that that will, if not trap, will be hazardous to environment and
Yeah.
will do no good to have inhabitation around it. Got it, dear?
Yes, sir.
Those who are reveling in that area, the dwellers of the area around them, will not be served any good by liberation of methane gas. Is it okay?
Yes, sir.
But yes, if we are able to tap it, if we are able to trap it, which we will do in the next segment when you are using biogas, primarily you are using methane gas. So if you are able to, it is all for your good. Is it okay?
Yeah.
So barring a few which can be easily discounted on, as there is not much merit to be found there. So what we are to say, it is all win-win to us to have a hydroelectric plant and it is a renewable source of energy, right? Yeah.
Yes, sir.
Okay. So this being with hydroelectric plants, of course, hydroelectric plant has one major contention. Not everywhere it can be. It cannot be constructed given anywhere willy-nilly. You have certain places of greater utility than the others, right? Yeah.
Yes, sir.
Okay. Then, what are the other forms which you may find some interesting? Tell me. Few forms which you may find interesting. Few energy forms, few energy source, or few energy which are not yet source to me. Few energy which are not yet source to me, energy retaining object, energy retaining phenomena, which are not yet source to me. But what should draw your interest? In times to come, maybe you will be able to devise a methodology by which that energy can be tapped.
Yeah.
Okay, that can be
Yeah.
energy which you are getting out of lightning. Think about it.
Yes, sir.
If you are able to predict that, okay, there is where lightning is to take place and there is a device placed which can tap that energy, you will be beneficiary and that is good quantum of energy, right? Yeah.
Yes, sir.
10 to 11 years down when I was to drive in Patna and it used to be very hot at that time. And the roof used to get heated and the car was non-AC at that time. I used to think that why can't we convert this energy, solar energy, into air conditioned energy? Because
Yeah.
we are feeling hot, right? We are not using that energy. And at the same time, we can be beneficiary of that energy if we are able to convert it into energy electrical, which will be used to operate air conditioner, correct? Yeah, of the car
Yes,
person.
sir. Yeah.
Isn't it? So
Yeah.
now yeah, that is gaining momentum. Solar panel as gaining momentum, right? Yeah. So
Yeah.
one solar panel can get you around 0.5 volt to 1 generation, volt generation, and around 0.7 watt of energy. One panel
Yeah.
from 0.5 volt to 1 volt, it can generate and it can get you an energy supply of 0.7 watt. That means 0.7 joule per second. And we are using this. Recently, it was used in Mars orbiter.
Yeah.
Solar energy was used in Mars orbiter. It is used in many a gadget. It is used nowadays in electric signals, right? Yeah.
Yes, sir.
Okay, so we are using we use in watch, we use in toys. So there are various places where solar panel being fitted or solar energy being made good of. Correct? Yeah.
Yeah.
So solar energy, solar panel, and the best thing about them is you can place them on deserted area which are not of use, area which are not inhabited. You
Yeah.
can make good of those areas as well by simply placing them. There is hardly any maintenance required.
Yeah.
Yes, they are high on cost, of course. Why? Because one is connected to other with the help of silver belt. One panel to other panel, you require silver belt connectivity. And silicon, which we require, silicon is present in abundance, but higher grade, higher quality, better quality silicon being required. So those are not to be seen that readily available, like silver and silicon of high order. Yet, yet what we get out of initial investment is a supply without hindrance, without maintenance for quite a longer period of time, right? Yeah.
Yeah.
And India is bestowed with good amount of sunlight. So we are land blessed with good amount of sunlight, right? Yeah. So we should
Yeah.
try sun energy, right?
Yes, sir.
So that is what is drawing attention now, and it has gained ground in last few years. Also, we have other forms of energy, as you know, it can be tidal energy, it can be wind energy, windmill we use, right? Yeah.
Yeah.
With windmill, at least there is a part which is rotating, so there is mechanics involved. But with solar panel, there is no mechanics involved. There's nothing to rotate.
Yeah.
Okay, so there also solar is weighing higher than windmill. But we do have windmill, correct? Yeah.
Yes, sir.
So there also, and that we know that as the wind blow from higher pressure to lower pressure, because when we are moving up, temperature is decreasing, right? Yeah.
Yeah.
And then wind will blow from high to lower, and if we apply this conversion, if we get this conversion able to make the blades of fan or windmill rotate, then we can generate electricity, right? Yeah.
Electricity. Yeah.
Okay, so we
Yes,
know
sir.
those. We know about tidal energy as well. They are also trying to develop nowadays energy by pressure. And what they will do, they will place those footpad everywhere where more number of footfalls being seen, be it mall, be it train, be it local train, be it places of worship, okay, where people are to throng. So those places, what they will do, they will put the pads, and those pads are dependent on pressure. If you place your foot on it, your feet on it, then they will be getting compressed, and as they get
Okay.
compressed, then you will get energy generated out of pressure differential. So they are trying to get this also for energy. This will also get you energy, right? Yeah, without much of,
Yeah.
correct. So they are also
Yes.
trying to get this. That will take time, but these are few things which are to come in future, and very interesting for us to find a way out, to get more and more tapped. Because energy, we know, cannot be destroyed, but it's difficult to tap that energy to make good of it. Correct?
Yes, sir.
Okay. Now, also tell me one very important. Methane, I told you, is not being used when we are talking of hydroelectric plants, right, dear?
Yeah.
A very important source of energy, you know what it is, dear, and that is important more so in remote areas. I'll say in the areas which are countryside areas, there you are finding much uses of this source of energy. Countryside, they are outskirt of. I'm not talking of
Yeah.
urban, I'm
Yeah.
talking rural areas. Rural areas, right? Yeah.
Yeah.
So there, what you have essentially something which you call biomass.
Yeah.
Is it okay?
Yeah.
So what is biomass? What is biomass to you? Tell me, dear, what is your understanding on biomass? Yes, Rishabh, you first.
So is it bio so biomass is
What is your
bio
understanding?
in biomass form of energy we use any organic matter to liberate energy,
Okay. And what
such as
is,
wood.
yes, dear, continue.
Such as wood can be used as a fuel to release energy.
Correct. Correct. I'll take wood for example. Fine. Let us say wood, dear. It would have been in uses since time immemorial, right, Rishabh?
Yeah. Yeah.
We are using wood as source of energy, and it is being used for long now, time immemorial, you can say. We are into uses. But more than wood is the calorific value. Calorific value means energy. Okay,
Okay.
energy is the heat capacity to heat, right? Because we'll be essentially using it to heat, correct?
Yeah. Yeah.
Calorific value. So more than the calorific value of wood is the value of charcoal which we get from wood.
Yeah.
Okay, wood, we are getting charcoal from wood only.
Yeah.
But it has more heating energy, more energy to produce heat. It produces more heat than what can produce wood, right?
Yeah.
So how you convert wood in charcoal? Because charcoal will be then of more interest than wood per se, correct?
Yeah.
So what we do, we heat wood. We
Yeah.
heat wood and we heat in limited supply of oxygen.
Yeah.
Anaerobic heating.
Yeah.
You're heating it, you're burning it, but you're burning it in limited supply of oxygen.
Yes, sir.
So if you'll burn it in limited supply of oxygen, then you will get rid of water trapped in wood.
Yeah.
Are you getting it?
Yes,
You
sir.
will get rid of water trapped in it. And if you're getting rid of water trapped in it, if you're getting rid of volatile material which are in it, then what are you to get it converted into? You are getting it converted into
Charcoal.
charcoal. And charcoal will have more calorific value than wood per se,
Wood.
as it is free of moisture, right? Yeah.
Yeah.
So that is one form that we are using. But I was talking, fine, you can call it, you can. But I was talking of what is quintessentially called biomass. Quintessentially. What is quintessentially called biomass? You are moving on that, you were doing that line, but you got slightly digress. You are talking something related to manure. You are talking something related to decomposition, right? Yeah.
Yeah.
Vegetable crops, decomposition of vegetable, decomposition of crops in the rural areas, right? Yeah.
Yeah.
Decomposition of liver stock or waste of liver stock, right? Yeah.
Yeah.
So as in more cases than one, I'll say, I'll not make any blanket perception out here, but in more cases than one, you relate biomass with cow dung.
Okay.
Okay, so we also call it gobar gas.
Yeah.
Okay, we relate it with cow dung, so it is also called the dialect, the vernacular dialect is gobar gas. Is it
Yeah.
okay? So what
Yes,
we
sir.
do, we mix cow dung with water
Yeah.
and make a slurry. Slurry you say, sludge you say, ooze you say. Okay, there are different names. Mire, you can also call it mire. You can call it
Yeah.
muck, mire, slurry, ooze, whatever. Alluvium is also, it is also called alluvium.
Yeah.
So if I'm mixing cow dung with water, I'm getting slurry, and what will I do of this slurry? I'll let
Burn.
this slurry be in a dome-shaped structure for 3 to 4 days.
Okay.
And I'll see there is no supply of oxygen to it, no supply of air to it. Is it okay?
Yeah.
No supply of oxygen to it, no supply of air to it. Why is it so, dear? Why I am not letting oxygen supply to it? Because I am looking forward for which reaction again? Anaerobic.
Anaerobic.
And anaerobic reaction will take 2 to 3 days. It in general takes the complex material of the cow dung to break into simple organism or material elements. If I am to, then it will take 2 to 3 days. Okay, the complex
Yeah.
structure will break down. The complex structure will break down, but I will take care of that. There is no free supply of oxygen. It's not that they are to get free hand. Clear, dear?
Yes, sir.
And then in anaerobic state, if you let it, in about 3 days time, right? Yeah.
Yes, sir.
In about 3 days time, you will see that the dome-shaped structure will get you 4 gases. Okay? The
Yeah.
closed structure will get you essentially four gases. They
Okay.
are methane, methane, hydrogen, hydrogen, carbon dioxide. What did I say?
Carbon
Carbon
dioxide.
dioxide and hydrogen sulfide.
Okay.
But the major, to the extent 75%
Methane.
will be methane. And
Okay.
methane can burn, as you know, right? Yeah.
Yeah.
And it has got good calorific value. And not only that, we also stand gain on there'll be no ash.
Yeah.
Charcoal when will burn, wood when will burn, it will leave ash, right? Yeah.
Yes, sir.
But here you get without of ash.
Yeah.
So we get methane, which we'll use as source of energy. And then you may ask, but what about the mire which is left? What about the slurry which is left? Fine. Not all
Yeah.
are to get converted. Some part of slurry will be left. Yes, they are to be cleaned, but you can use them as manure, right? Yeah.
Yeah.
We are
Yes, sir.
benefited both way.
Yeah.
Okay. Two shot in one, right? Yeah.
Yes, sir.
So this is one of the very pronounced use we are finding nowadays in the remote areas, outskirts of a city. Why did I say outskirt of a city? Is because you are not to get liver stock in the city anymore, right? Yeah.
Yeah.
So generally in the outskirt we do get. This is source of energy. Fine?
Yes, sir. So 1 second.
Yeah.
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 Yes,
Now,
sir.
what else we do have in this chapter? Take a read, please. Take a read on different source of energy that you do have. Tidal energy, you have
Geo.
ocean energy. Tidal and all are not that relevant, but yes, they are huge. About 5 years ago, when we were in Puri, I was thinking of the state that tides are coming, right? Yeah, just think of when you are visiting any place. Tides are coming, huge energy they are carrying with it. If they're carrying
Yeah.
huge energy, why can't we make good of this energy? Because they hit, and after of hitting, they are getting lost. So that energy, if we find a device, if we devise a methodology by which that energy can be tapped, it is all good for mankind. Correct? Yeah, it is all good for humankind. So yes or no?
Yes, sir.
So that is tidal energy. We can make good of tidal energy and other form of energy. Also, sea, sea has got different levels at night and in morning, correct? Due to pull
Yeah.
off.
Moon.
So that energy also we can make good of. The level rise and fall of level also can be made good of. They are all used to rotate turbine to produce electricity.
Okay. And
Okay.
also there's geothermal energy.
Yeah, geothermal energy. Tell me what be geothermal energy. What do you mean by geothermal energy? Take a read.
Geothermal energy means energy stored as heat in the earth. You know
Yes.
that below the earth's crust lies a layer called the mantle.
Core of Earth, as you know, is in the molten state and very high pressure, right? Yeah.
Yeah.
Not actually the core. Now we got to know that core is not, but around the core is. So around the
Yeah.
core in molten state, and then that state, if you go get a vent to, because the tectonic plates are always in motion, right? Yeah. The
Yeah.
tectonic plates are always in motion, and then you get a vent, and that vent produces geyser. Why?
Okay.
Because you have water table and heat, it is heating from beneath. So what will happen? It will produce steam.
Yeah.
You don't get everywhere. In New Zealand and in US, you have in abundance this source of energy.
Yes.
In New Zealand, in particular, you have good quantum of springs. So if you get spring, then that is another source of energy in a way. Without doing a thing, we are getting energy, right there.
Yeah, yeah.
Okay. So that is that part of energy which they have referred to, isn't it?
Yes, sir.
Okay, yeah. And anything else?
So they've given the working of a biogas plant,
Yeah. That is
and
the structure, slurry, and all the YouTube and how you're getting methane. So that schematic diagram should be there with you. You should be in a
yeah,
position to. Yeah.
and then there's ocean thermal energy conversion.
Ocean thermal energy conversion is the same which we just now spoke of. Just read once.
Yeah, so solar energy falling on the surface of the ocean warms it. The water at the surface of the ocean is warmer than the water deep below. Generally, the difference in temperature is about 20 degrees Celsius between the surface water and water at depth of 1 kilometer.
And they use ammonia. Keep on reading.
Yeah. This temperature difference can be used to operate an ocean thermal energy conversion plant. Clearly, the ultimate source of the stored thermal energy of the ocean is the sun. In one system for OTEC, a fluid with low boiling point, such as ammonia or chlorofluorocarbon, is used as the working fluid. Warm seawater is used to vaporize liquid ammonia in an evaporator. The expanding vapors of ammonia turn a turbine connected to a generator. Then the vapors go to a condenser. There, cold seawater pumped up from the deep is usually used to liquefy the ammonia. This ammonia is reused and the cycle goes on.
Yeah. So this is the natural process basically, which we are making good of. The difference should be 20 degrees centigrade minimum. We are using
Yeah,
ammonia, vaporizing, and then we are compressing it. Compressing it, or
yeah,
we are using temperature to get it liquefied.
yes, sir.
Okay, that these being inside of the ocean only taking place, and
Yeah,
it's a continuous process. This
yes, sir.
also can generate energy, right, dear?
Yeah,
So Rishabh, coming 14 days, I'll be slightly occupied because, as I've told you, that another certification is into coming from IIT Kanpur. So after 14 days, I may put you through a test, as the other student are also to put to a test, and that test will be your competency on physics. Physics being done with you, mathematics and chemistry. Those who are mathematics, they will take for physics, chemistry. Those who are chemistry over here, they will take for physics and maths. So you will be taking for chemistry and mathematics to see that you are competent on those two subjects or not. And if you do qualify, then we'll get into association on those two topics, subjects, a few topics on those subjects, or complete per se the subject. Is it okay?
okay.
What books are you referring for now in
Right
maths?
now, for mathematics, I'm referring R.S. Agarwal and NCRT.
R.D. Sharma, you have not got?
No, sir.
R.S. Agarwal, are you solving?
Yeah.
And chemistry?
Chemistry, I'm referring NCRT itself.
My Manjeet Singh, you don't have?
No, sir. Search up. I'll search it
No
up.
text, no reference book?
No, sir. I'll find one. I'll buy one.
Manjeet Singh you buy. Manjeet Singh and Lakbir
Okay.
Kaur. Okay. And then mathematics you buy R.D. Sharma as
Okay, sir.
well. Okay, yeah. Shall we keep to this today?
Yeah. Okay, sir.
Uh, Thank you. Thanks a lot.
Thank you, sir. Bye.